Okay, I have to admit, when I first scanned the source material for today, I just sort of stopped cold at the price tag.
Yeah, I can imagine it's a big number.
We're looking at a Kramer CLS-AOCDP-98, and it's on sale for $720.
Right, on sale, the list price is 900
That's a mortgage payment for a single cable.
for something that, at first glance just looks like a wire.
So the mission for this deep dive is pretty straightforward. Convince everyone listening, that a 30-meter DisplayPort cable can possibly be worth that much. What are we actually paying for here?
Well, you're paying to defeat physics, basically.
Okay, that sounds a little dramatic.
It is, but it's also kind of true. I mean, standard copper cables, they have a really hard limit.
Right.
You try to push high bandwidth data like 4K video at 60 hertz through copper, and after about, 3 or 5 meters, the signal just disintegrates. It's called attenuation.
So the electrical resistance just builds up. And usually, if you wanted to go 30 meters, you'd need a repeater or some kind of extender box in the middle to boost the signal.
Exactly. And those are all extra failure points. This Kramer cable, though, is an active optical cable, an AOC.
Active optical.
It effectively smuggles a tiny fiber optic transceiver inside the connector head. It's a bit of a wolf in sheep's clothing situation. It looks like a simple cable, but it's actually a pretty distinct piece of hardware.
So let's talk about that active part. Usually, active cables are kind of a pain because they need external power.
Yeah, you're looking for a spare USB port or a wall outlet just to run the cable's own electronics.
Which is just another thing to manage.
But that's the first big differentiator here. This is a hybrid cable. So inside the jacket, you have multi-mode fiber strands doing all the heavy lifting for the video data. But running right alongside them are good old-fashioned copper wires.
So I'm guessing the copper is there to pull power.
Precisely. It siphons just enough power from the DisplayPort source itself, usually from pin 20 to run the optical converters. No external power needed.
Oh, that's clever.
And it also uses that copper for the digital handshake, the EDIDE and the HDCP 2.2 compliance.
That handshake is so vital. That's the conversation where the computer tells the monitor, hey, I'm allowed to play this copyrighted movie, or here are my correct resolutions.
Right. And pure fiber solutions sometimes struggle with that because they're really just one-way pipes for light. By keeping some copper for that low-speed data, Kramer gets the best of both worlds.
And that high-speed video part it's a huge deal. We're talking about high bitrate 2 standards.
Yeah, 21.6 gigabits per second. That's the bandwidth you need to push uncompressed 4K at 60 hertz with full 4.4.4 color.
Which you'd never get over 30 meters of copper.
You'd get a black screen. With this, the fiber ensures the signal you get at the end is identical to the one you started with.
Okay, so a lot of the cost is the miniaturization of all that tech. But what about the physical build? I mean, fiber optics have this reputation for being super fragile.
They do.
If I'm an installer pulling this through a conduit in a ceiling, am I just going to snap the glass inside?
That is the common fear, for sure. But the specs here suggest otherwise. They've reinforced this thing to withstand 500 newtons of crush pressure.
Which is, what does that mean in real life? Can I stand on it?
You could easily stand on it. And it has a pulling strength of about 10 kilograms or 22 pounds. But the spec that really surprised me is the size.
It's tiny.
This whole thing is only 3.4 millimeters in diameter.
That's incredibly thin. Most of my DisplayPort cables are these thick, stiff things.
Right. And that connects to airflow and just ease of installation. This is thin, flexible, and has a tiny 6-millimeter bending radius. You can snake it almost anywhere.
Let's touch on the safety rating mentioned in the datasheet, LSHF.
Low smoke halogen free.
Yeah, that sounds like pure marketing jargon to the average person. Why does it matter?
It matters a whole lot if you're in a commercial building. Standard PVC cables, they often have halogens in them.
Okay.
If they catch fire, they release chlorine gas, which turns into hydrochloric acid when it hits moisture, like in your lungs or your eyes.
Wow. So in a hospital, an airport, or a crowded office building, that's a massive liability.
It's huge. LSHF means if it burns, there's very little smoke and no toxic halogen gas. In a lot of places, it's actually illegal to install non-LSHF cables in public plenum spaces. So part of that $700 price is simply the cost of safety compliance.
You know, it seems like such a niche product until you realize that every digital billboard, every airport flight screen, every medical imaging display, they probably all need something exactly like this running behind the wall.
That's the real takeaway here. We're
Mhm.
getting to an era where passive copper just can't keep up with the data rates for 4K, 8K, and whatever comes next.
So the cable itself has to become an active, intelligent machine.
It has to, just to move the data from point A to point B.
It really blurs the line between an accessory and hardware.
It absolutely does. It's no longer just a wire, it's a component.
That leaves me with a final thought then. As these data needs keep growing, will all our cables eventually have to become active machines instead of just passive wires? A lot to think about. Thanks for exploring this invisible infrastructure with us on this deep dive.